Hi everyone, this is a condition monitoring for predictive maintenance using vibration sensors and machine learning in collaboration with Visata from Luxembourg. This is a setup. We have some motors for our chillers for the HVAC system. And the setup is that we put in the vibration sensor here. We are using the Banner Engineering vibration sensor stuck onto the motor and wired up to an industrial IoT gateway. The full architecture looks like this. The vibration sensors cascading here, wired into the IoT gateway from SIA Connect. And it's using the internet connection from the industrial cellular router from Bright IoT. And it's sending data into the AWS IoT core and then straight into the Visata platform. Now, typically, this is what you get. We have bind some data points to our model. So the vibration sensors and the motors, and we have attached the data point that are streaming in to the model. And then we can visualize the data with an explorer like this. Now the problem is that the user has to be able to understand the vibration data. You have to know what RMS vibration, RMS acceleration is, peak velocity, peak accelerations, what are kurtosis, and what are the crest factors. So vibration experts amongst yourself will understand those, and you have to understand whether the vibration sensor is scanning from what frequencies, and then interpret the information. So here I've put in the RMS vibration in both X and Z axis. Notice straight away one of the motor is having problem because they are the same motors, same size, and one is having a significantly higher overall vibration than the other. Particularly on the Z-axis, which is the rotating axis of the motor, so it's struggling in that sense. Not as much in the shaft, but it's still having problem, and you can see probably a event here, maybe some impact or something going wrong. This is already powerful. I mean, the platform that can set up date range, telling you and being this fast in rendering, getting the results, zooming in, zooming out. But the issue still remains that you have to be able to understand the vibration data. And 80% or more of the typical end user would not understand vibration data, or they would have to go and learn those information and then figure out what sort of set point do they have to do, what sort of value set point they have to make in order to do the alarm so that they can do some predictive maintenance or even prescriptive maintenance. Now I've put in the two line here. This yellow one is the unacceptable level for a small machine, and the red one is the unacceptable level for a medium machine. Now the yellow one, the motor number 2, is really in need of maintenance, but it hasn't failed yet. But we would have to figure out where do we put the alarm. And this is basically looking at one parameter of the vibration sensor, which is only the RMS velocity. Now, to consider the bearing, we have to go into the range of the acceleration at a higher frequency, and much more understanding is needed to be able to figure out how to set alarm, set events, so that we are detecting an onset or trending of the error. But you don't have to do any of that because we have made a machine learning model for you. And the machine learning model is able to tell us the general condition of our assets in a SCADA type of dashboard. It's telling me that one of my motor is in a critical condition and two of them are currently disconnected. Now let's dive into more details. So it can interpret based on a 0 to 10 scoring of the condition. So we have built a model to benchmark that and provide information in a contextual format, saying that what are the current condition of each motor, and we are able to drill down into see each individual motor. So based on the vibration sensor, it's interpret that the motor is in an excellent condition, motor 1, and it has given some context that either impacts and the running condition, these two are it's the worst, but it's still in a good condition, with some forecasting of the future. So it will last at least 112 days. So this is based on lubrication, but structural condition seems to be the issue, which corresponds to up top here. And the bearing condition is also in a good condition. So let's go back to the motor 2. Okay, for motor 2, it's saying it's in a critical condition. The fault percentage gives some indication of where the problem is. It's mainly in the misalignment and imbalance resonance area. Not so much about bearings. I suppose you can tell from where the vibration, what frequency they are, and other factors based on the parameters reading from the vibration. And here are some recommendations along with the remaining days before failure. What it's saying is like 0 date. So these are some forecasting of day to unacceptable level. The way we determine the unacceptable level is from initial teaching of the model. So we can run the training right after maintenance, or we'll choose the baseline based on the best condition motor, and we can then forecast up to an unacceptable level. And here I will go back to other motor to see the forecasting. Here, so it's giving some indication of when to do the lubrication, when to check the structural condition, and when to check the bearing. So here we have the overview of the current status of your assets. If you want to dive deeper and see more detail based on the individual score, you can do that, and then go into each motor to see the health and the details and make some planning on when to do the maintenance. Here's the example of a motor in the bad condition. So we can set an alarm based on the machine condition grade, so we can have a more accurate time to do the maintenance. And finally, if you need to drill down and see the data and do a deep dive, this is possible also with the Explorer. So we can do a more detailed deep dive, see events, see things in a fine-grained detail. All right, thank you very much.